Good morning, welcome to sunny San Diego. Good to see you guys here. I'm Jens. I represent the continuous delivery team at Airbnb. Most of the continuous delivery folks are actually up here too. You might have interacted with some of us on Spinnaker Slack, so it's actually nice to meet you guys in person. You might have expected Brian Wolfe to be here as well. Unfortunately, he couldn't make it. He's actually becoming a dad, so he's taking care of a different kind of delivery, so he won't be able to make it today. So yeah, without further ado, who am I? So my name is Jens. I'll save you the pronunciation of my last name for another time. I'm originally from Belgium, moved to San Francisco about 6 years ago. Funnily enough, I actually started out as a front-end engineer, started working on developer tools, and now I'm like an infrastructure engineer these days. So I'm on Airbnb's continuous delivery team. We are about 6 engineers and then a PM and a TPM, and we are basically driving Spinnaker adoption at Airbnb. You can find my social media handles there. I'll put the slide back up at the end in case you want to follow me or something like that. So yeah, what is this presentation about? So brief overview. We're going to go through kind of an introduction. Why is Airbnb adopting Spinnaker? What is our tech stack? What value can Spinnaker provide for a company like Airbnb? How do we actually use Spinnaker at Airbnb? We do some special stuff. How do we run Spinnaker at Airbnb? What's our setup? How do we deal with like scaling Spinnaker, things like that. We've also built some custom extensions into Spinnaker over the last year. I'm going to give you guys some tips on how to easily extend Spinnaker, what sort of extensions we've built, and kind of give you guys some insight on how we actually use Spinnaker as a platform for CD, rather just as a software itself. And then, of course, we are migrating to Spinnaker. So our goal is to migrate all of Airbnb to Spinnaker. That's a pretty huge undertaking. So Airbnb runs about 1,000 microservices. So convincing all of these engineers, all of these teams to move to Spinnaker is a whole undertaking. And so I'm going to talk about how we approach that, how do we reach out to those teams, and how do we basically convince them to adopt continuous delivery and Spinnaker itself. So yeah, let's start back in 2009. Airbnb was just founded. This is a picture of Nate. So Nate is one of the 3 founders of Airbnb, and you're looking at a pretty historical piece of code right here. This is the very first commit to Airbnb. It's Rails in it. It says a lot about our history. We're still running Rails 10 years later. So that decision is actually pretty crucial, and that decision probably also plays a role into why we've adopted Spinnaker. Still using SVN back then. We migrated to Git later on, so this is very old, very historic. So this Ruby on Rails app grew and grew and grew and grew over the years, up until the point where it became monolithic, therefore dubbed Monorail. It's pretty infamous at Airbnb engineering these days. So Airbnb was written in Ruby on Rails. Our front end was Backbone back in the days. We transitioned to React Redux, and then our backend is obviously Ruby on Rails, and we were starting to build some early Java services. That's a few years ago when I joined Airbnb. And we use Rescue, which is basically Ruby on Rails' job queue to kind of do asynchronous workloads. And so how do we deploy this monolithic Ruby on Rails app? We actually decided to build an in-house CI/CD tool called Deployboard. So Deployboard is actually also written in Ruby on Rails, and we really like Ruby on Rails at Airbnb. And so Deployboard was our in-house deployment tool, and that worked pretty well for deploying this kind of single monolithic Ruby on Rails app. It basically gets events from GHE, GitHub Enterprise, displays the status of builds, kicks off CI, and then allows us to deploy. Monorail runs on EC2. We use Chef to kind of provision the EC2 instances, and then we deploy an artifact onto those EC2 boxes. So that comes with a bunch of problems, mutable infrastructure and all that. So that's one of the reasons we are now transitioning to Kubernetes. So this is an example of a Deployboard deploy. This was quite a while ago, back when Monorail had 1,800 EC2 instances. And so Deployboard will actually visualize the status of a deploy. So you can see all of these EC2 instances, and then you can kind of see how Deployboard kind of progresses through a deployment. So the green boxes are running the new version. The blue boxes are basically preparing, they're downloading the artifact. And then the yellow boxes are actually offline. They're not serving any traffic. They're basically being swapped out. That's where we're actually starting the new build of Monorail. So deployboard worked pretty well, but it had a set of problems. One of these problems is actually the rapid growth of Airbnb. So just to put things into perspective, back in 2009 when Nate created a Rails app, there were a couple hundred listings, maybe across the United States, mostly in the major cities, but Airbnb was still a very small company. It was still a startup, basically, kind of scaling. 10 years later, there are Airbnb listings all across the planet. Some of you might be staying at an Airbnb, I don't know. And there are millions of listings, and there are millions of guests every night staying in an Airbnb. So there are 6 million homes on Airbnb in 81,000 cities and 191 countries. So practically every country on the world, you will find an Airbnb somewhere. And so as we scaled the company, our engineering headcount grew. And so this Ruby on Rails app really started to grow into a monorail. We had thousands of lines of code. We went from a dozen engineers to 100 engineers to 500 engineers to 1,000 engineers, all committing to this single code base. And so it became really difficult to deploy this monolithic Rails app. We had to build a lot of custom queuing mechanisms, basically, to deal with deploying this monolith. So what did we do? We basically started kind of an effort to migrate to SOA. SOA is service-oriented architecture. So what we wanted to do is we wanted to split up the monolith and build microservices that all serve like their own purpose and that are easily to deploy like independently. So each team could basically own their own service. So what did we do with Monorail? We actually split Monorail into 2 repositories, I guess 2 monorepos. I guess you could call it dual repo if you really wanted to. So we're actually pulling Monorail apart into a repo called Hyperloop. So Hyperloop, you can think about it as the next evolution of a Monorail. That'll be our front-end monorepo. So it'll host all of our front-end code. We use Node.js for server-side rendering, and then we use React TypeScript on the front end. So basically, Hyperloop will house all of our front-end code. And then on the other side, you see Treehouse. So Treehouse is the name of our Java monorepo. Why Treehouse? Legend goes that the most popular listing that's a Treehouse was on the island of Java. The Treehouse repository holds a bunch of Java code, therefore it's named Treehouse. So we're really in the process of kind of pulling apart Monorail into Hyperloop and Treehouse. And so eventually in this beautiful future, we'll just have Hyperloop, Treehouse, and we'll get rid of Monorail. We'll just have a bunch of microservices. Today, we're still very much here. Monorail is in code freeze, so people aren't actually allowed to add any new features to Monorail. But of course, there's security fixes, bug fixes, people pulling code out of Monorail, and we think it's going to be around for a couple years to come because it's really millions of lines of code. It takes a while to kind of decouple a monolith like that. That's probably a talk on its own. And so while we were kind of moving to SOA, things were okay, but it kind of started falling apart. We started seeing errors. People started panicking in Slack. We started seeing failing tests. We started getting a bunch of incidents. We started to realize that our existing deployment infrastructure wasn't actually built for a microservices architecture, and we started seeing some of the cracks in our infrastructure. So what are some of the deployment challenges that we faced in SOA? So one thing in Deployboard is a great tool, but it doesn't enforce you to deploy certain environments in a chronological order. So you can basically click the deploy button and you see staging, canary, development, production. You can just go straight to production. There's nothing that stops you from doing that. So while Deployboard is good at deploying, it's not good at like orchestrating different stages in the deploy process. So it's not a deploy pipelines tool. There's also no codified deploy process. So imagine thousands of services. You want to deploy, I don't know, the payment service. You open the deploy button, you see a bunch of environments. You absolutely have no idea how to deploy the service. How do I know whether it's healthy? How do I know which tests to run? So there was no kind of codified deploy process. There was no best practices to deploy a service from development to staging, canary, and then production. So what ended up happening is that teams ended up writing these these runbooks. They basically started writing these runbooks, and they were like, oh, if you want to deploy my service, please read this guidebook. It'll take you half an hour to read through, and then you know how to deploy my service. So not a great process. And on top of that, we started investing a lot in integration testing and sort of like post-merge testing. We built a bunch of great tools, like for example, a tool that runs Selenium tests, traffic replay, fault injection testing. But because we didn't have a deployment pipeline, we couldn't actually enforce people to run these validations along the deployment process. And so these validations were basically running asynchronously. Best case scenario, someone might run them. They might look at the dashboard and see that their integration tests are failing. Worst case scenario, people are actually not even aware that there are integration tests, and they just deploy straight to prod. They have a postmortem, and then they figured out, oh, our integration tests were failing. So we really needed kind of this like deploy pipelines, this orchestrated deploy process. This is a picture of me last year trying to keep things alive. These days with Spinnaker, things are much better. My heart rate came down. It's much better now. So yeah, this is what happens when you click the deploy button in deploy board. Which environment should I deploy to? Should I publish the IDL client gem? Should I deploy to production? There's multiple red environments. Is red production? I don't know. Is green good? No one actually knows. It's really difficult to deploy a service. Therefore, people started writing these runbooks. We really needed deployment pipelines. It was pretty bad. In comes Spinnaker. You've all heard about it. This was our holy grail. This was certainly going to help us with continuous delivery. So why did Airbnb adopt Spinnaker and not one of the other tools that are available? Spinnaker has been proven at Airbnb scale and larger. So Spinnaker's been running at Netflix. It's been running at Google. Airbnb is like a pretty sizable company. So at least we had some data points of like other companies in the industry basically running a tool like Spinnaker. We were also migrating to Kubernetes. So we use Kubernetes to run our microservices. And so deploy board was built to deploy EC2 instances. It was built to do this kind of mutable infrastructure with Chef. And so we would either have to build Kubernetes support into deploy board or adopt a solution that comes with native Kubernetes support. There's obviously an active open source community. You guys are all part of it. You guys are all great. And so rather than having 5 engineers at Airbnb building our own custom tool, we basically wanted to collaborate with you guys. We wanted to leverage what the other people in the industry are working on. But most importantly, Spinnaker is built with the concept of deploy pipelines at its core. Deploy board didn't have deploy pipelines. It didn't do like release orchestration. And so one of the biggest drivers for us for adopting Spinnaker was that it was actually doing these multi-stage, multi-cloud releases. On top of that, Spinnaker is very easily extensible. We wanted to have a platform that could help us like fit Airbnb's needs. We have a lot of custom infrastructure at Airbnb, custom integration test tooling, custom CI systems, things like that. And we wanted to make sure that we actually adopted a tool that was easily extensible. Bonus points for Spinnaker being written in Java, which is also what our tech stack is, and TypeScript React on the front end. So our engineers are pretty familiar with the code that Spinnaker is written in. Comes with automated canary analysis out of the box. We had a bunch of incidents. We figured if we had canary analysis, we probably would have saved Airbnb.com from going down. So either we would have to build our own canary analysis tool, or we could just adopt Spinnaker that comes with that out of the box. So how do we run these microservices at Airbnb? So we have a pretty particular way of running Kubernetes services. We have a framework that we call OneTouch. It's basically an abstraction layer on top of Kubernetes. It's in fact just a command line tool that reads a bunch of configuration files and will then like output the lower level Kubernetes manifests. So product developers at Airbnb don't actually need to know how to set up a replica set, a deployment, stateful set, all of these kind of Kubernetes constructs. They can basically write a higher level YAML file that will then generate all of the Kubernetes infrastructure for them. And so OneTouch is not only a framework, it's also kind of a philosophy at Airbnb. We have every service starts with an underscore infra folder at the root. And so in that underscore infra folder, we will commit all of the configuration for your service. How do you run CI? How do you do alerting? Where are your dashboards at? What are your deployment pipelines? All of that lives in the underscore infra folder. And then with a single touch, with one commit, you can actually change your service's source code as well as its configuration. So everything kind of lives with your source code, which is a great way of doing things. It's very easy to kind of roll back configuration changes together with source code changes. You'll have all of that kind of in your Git history. So it's standardized across Airbnb. All Kubernetes services use OneTouch. There is a command line tool. You can basically say like, hey, OneTouch, give me a Rails service. It gives you service discovery. It gives you end-to-end encryption. It gives you IAM roles. It gives you a CI setup that you can then plug jobs into. And it will eventually give you Spinnaker deployment pipelines, how to deploy your service. So it's basically a framework that's built by infrastructure, and then different infrastructure teams will basically plug components into the OneTouch framework. But eventually, there is a generate step that runs at build time. All it does is it basically generates Kubernetes YAML, and then we basically feed that into Spinnaker, and then Spinnaker understands how to deploy that, and then it basically goes and deploys your Kubernetes servers. So when we first adopted Spinnaker, we kind of had a conflict. We had Spinnaker not written at Airbnb, and then which was also, we wanted to run Spinnaker on Kubernetes, and then we had OneTouch. We wanted Spinnaker to be kind of a native service at Airbnb. So what we did is we basically run Spinnaker on this OneTouch framework. So we opted not to use Halyard. We basically wanted to use the tools that are standard to Airbnb for configuring services that will make it easier for us to kind of dogfood our own infrastructure. So here's an example of a OneTouch configuration file for the DAC, the front-end service in Spinnaker. So basically, there's some parameters here. There's a port. We're using Envoy for service discovery. I'm giving it an IAM role. I'm giving it 10 pods. And so basically using OneTouch generate, this will actually spit out all of the sidecars. It will spit out HA proxy, Nginx, Envoy. It will set up end-to-end encryption and all that good stuff for free. It comes with a logging sidecar. So OneTouch is really kind of a nice abstraction layer for us at Airbnb to not have to build the same thing over and over. So basically what we did is Spinnaker publishes a BOM, a bill of materials, if you're not familiar with it. It basically tells you for every release of Spinnaker, this is a link to the container that we use. So what do we do when we upgrade Spinnaker? We basically have a file that fetches all of these containers from the BOM, and then we basically run those containers inside of our OneTouch pods. And so this is how we run Spinnaker at Airbnb. And so we basically run each of the services individually. We don't use Halyard to kind of orchestrate a Spinnaker release. So this is a setup, a pretty standard Spinnaker setup. So DAC and Gate are exposed to the public, to our internal network. Obviously DAC, that's how people deploy. Gate, we might have someone that actually wants to call into the API directly. Then we have all of the other services. We run Front 50, Kayenta, Cloud Driver, Echo, and Sporka. You might be confused, Sporka, why not Orca? So fun fact, OneTouch services are actually unique by name. Orca already existed. So Spinnaker's Orca became Sporka. So yeah, we had to deal with that. We run on AWS. Most of our services are backed by SQL rather than Redis. We read the Netflix blog post and we use a lot of the SQL stuff that's coming out. So we run RDS, Elasticache S3, and then we run Spinnaker on Kubernetes. So it's basically a OneTouch service. So how do we actually teach Spinnaker, how do we teach Spinnaker to deploy these OneTouch services? This is like an overview of what the deployment process looks like. So we have GitHub Enterprise. A developer makes a commit. That commit sends an event to our CI platform. We run our CI on BuildKite, which is a CI provider. And so what happens in BuildKite is there's a build step. So basically what we do is we pull all of your source code in, we run the one-touch generate command, which will basically spit out all of the Kubernetes YAML, and then we upload that as an artifact to S3. We actually also do build signing, so we encrypt the artifact when it goes onto S3. This protects us from someone tampering with the build while it's in S3 before it's deployed, so we can actually cryptographically verify that what we're deploying is actually what we built. We also built a Docker container, and that Docker container gets pushed to Amazon ECR, which is basically container registry. And so what happens in Spinnaker, we extended Cloud Driver. We created a new artifact type. That artifact type is a one-touch artifact. So what that artifact does is it pulls the tarball from S3, it decrypts it, it actually verifies the signature to make sure no one actually tampered with the builds, and then it basically concatenates all of the YAML files and tells Spinnaker to deploy that. So with our custom artifact, we can actually use the existing stages. So we basically just use the deploy manifest stage to then tell Spinnaker, like, hey, here's a Kubernetes manifest. Go and deploy it. That happens in Cloud Driver. Cloud Driver will deploy to Kubernetes, and Cloud Driver will basically monitor deploy, and that's it. We're good to go. So it was pretty easy for us to teach Spinnaker how to deploy one-touch services. We just had to create a custom artifact. That kind of shows how flexible Spinnaker is. You can teach it things like build signing relatively easily. We can actually deploy one-touch services with Spinnaker. So what we can do is we can deploy Spinnaker with itself. That's pretty neat. So we can actually deploy all of the microservices independently. So we make changes to Kayenta, Cloud Driver, all of these services. So we can actually use Spinnaker deploy pipelines to verify a Spinnaker deploy. Pretty meta, but also pretty awesome. So fun fact, Spinnaker lives in the MGMT-A cluster. We have different Kubernetes clusters at Airbnb. They are kind of air-gapped by AWS firewall rules. They're like the development cluster shouldn't be talking to the production cluster. Spinnaker lives in a special kind of management cluster, kind of a federated control plane cluster, and that cluster has special access to the Kubernetes API on all of the other clusters. So Spinnaker is kind of a special cluster that lives in this Spinnaker is a special service or set of services that lives in this management cluster. So this is Cloud Driver deployed with Spinnaker itself at Airbnb. So now that we have Spinnaker running, I want to briefly walk through some of the extensions that we've built for Spinnaker, why we've built those extensions, and maybe give you guys some tips on how to easily extend Spinnaker. So the first thing we did, we have this one-touch philosophy at Airbnb, and so what we needed was pipelines as code. This was about a year and a half ago, before the native pipelines as code was very popular. So we basically decided to run our own tool. We also wanted to run our own tool because that would give us more control and would basically allow us to create an abstraction layer for Airbnb developers. So we stayed within the Nautical team for naming the services related to Spinnaker. So we created a command line tool, Anchor. And so here's an example of a YAML configuration file that allows you to basically set up a pipeline. So this would be a pipeline for deploying a service. So it consists of 4 stages. First stage is deploy to staging. So it's a one-touch deploy stage, which will then basically generate a deploy manifest stage with the right artifact. And so we can basically set these dependencies on the stages similar to how Spinnaker itself does it, and this allows developers to kind of build this DAG of stages and allow them to easily configure their service. So how does Anchor work? Anchor is a command line tool. It's written in TypeScript. It runs at build time, so during CI. So you write your pipeline, you push it to CI. Anchor will basically generate Spinnaker JSON. So we'll basically generate like pipeline output that Spinnaker understands. So it's also an abstraction layer for Airbnb specific features and stages, maybe stages that aren't native. So for example, an integration test, we reuse the existing webhook stage. And so people will just kind of have this custom stage, and then under the hood, we can actually set up the webhook stage appropriately. New feature that we just landed in Kayenta this week and Anchor this week is that it can also generate Kayenta. So it can generate canary configs. So people at Airbnb also have like canary analysis configs as code. They can even go and share canary analysis configs with other teams. So for example, we have a canary analysis config for our service framework. And so every service that uses the Java service framework gets canary analysis for free out of the box. And our plan is to basically generate kind of these default pipelines for a new service. So if you spin up a new Rails service with OneTouch, you'll get like staging, canary, production, development out of the box. You'll get your deployment pipeline, and you're basically good to go. You have a new service in Spinnaker within minutes. So Anchor generates, it grabs YAML pipeline configuration, and then outputs JSON that Spinnaker understands. How do we actually deploy this configuration to Spinnaker? We bootstrap every Spinnaker service with a special pipeline. This pipeline is called the deploy continuous delivery configs pipeline. So what happens is you have a green build, it kicks off the deploy CD configs pipeline, so it's on auto deploy. And so what this pipeline does is it pulls the pipeline artifacts basically, also does the build signing and saves those pipelines, and then it also has a delete pipeline step. You might have a pipeline that's no longer in your configuration, so it kind of makes sure that whatever's in your configuration is the source of truth. We basically remove all stray pipelines. So this runs on every build, so you can now use Spinnaker pipelines as code. Every time you commit to master, it'll automatically kick off this pipeline, and it will actually update your existing pipelines. So you can deploy Spinnaker pipelines as if it was any other artifact, which is a pretty cool, useful workflow. So besides Anchor, we really think of Spinnaker as a platform rather than a bunch of services to do CD. We really want to build a CD platform, and we mostly extend Orca and Cloud Driver to do so. So we have Orca, and then we basically taught Orca to talk Airbnb Service IDL. So Service IDL is interface definition language. It is basically a typed language, basically Thrift. That's how like inter-service communication happens at Airbnb. So there's an existing webhook stage, the HTTP webhook stage. So we created a custom webhook stage that's basically IDL. So now you can actually leverage Spinnaker to talk to other services that are written in Airbnb's IDL language, and we can actually do things like trigger integration tests and kind of poll them. So Orca can talk to a bunch of different services. It can talk to our CI platform to kick off new unit tests or integration tests. It can talk to deploy boards to fetch some information because deploy board's still around. It can run things like fault injection tests and things like that. One thing we did is we extended Echo's event bus. So Echo is the kind of message bus service in Spinnaker. And so it's actually very easy to extend Echo. And we really wanted to send events for things that happen in Spinnaker and send those events and kind of fan them out to our existing infrastructure. So what happens, for example, there's an event, stage started. So someone kicked off a stage that comes into Echo. We actually have a custom parser for that event that then generates a new event. We can actually say like, hey, this was a OneTouch deploy stage. Someone deployed to staging. So we basically parse the existing Echo event and convert it into our own Airbnb internal event, and then we fan it out. We have a service that we call Jitney. So Jitney is a message bus. It's basically Kafka. It's basically an abstraction layer around Kafka. So we emit a Jitney event. We also fan out to Datadog. People might want to build dashboards and actually see their deploys on those dashboards. And we also fan out to our data warehouse so that people can actually run retrospective analysis on all of their deployments, like how many deployments do we have at Airbnb, how many regressions does Canary analysis catch, how many services do we have in Spinnaker. So we can actually kind of build like analytics on top of Spinnaker based on these events, and we can really do data-driven development. Here's an example of something that's consuming these events. This is Watchpoint. This is Airbnb's in-house observability tool. It basically shows you the service Avalon. So how it works is this is a timeline graph. So this is basically time. And then this line is where we're looking at. So what happened is a new deploy got kicked off, emitted a Kafka event. Watchpoint consumed this Kafka event, knew that a deploy started. So people can actually overlay deploys. There's some graphs here at the bottom that are useful for them. Let's say error rate. You can actually then very quickly correlate error rate going up with a deployment. And so you would actually know whether your issue is deployment related. It'll link you to other services that are up and downstream of the service that you're looking at, so you can kind of easily debug your deployment. So you can actually see the deploy got kicked off here, and then Spinnaker started deploying the pods. These are the requests incoming by SHA, by version. So you can see the new version slowly comes online, and then the deploy succeeds. So this is an example of how we use Echo to really integrate our existing tooling into Spinnaker, how we really easily extend Echo as kind of that like middleware layer to fan out events. Another example that we have is we use webhook stages for integration testing. We use both the HTTP webhook stage, and we also have a custom IDL webhook stage. So basically what we tell integration test framework developers at Airbnb is, hey, this is how Spinnaker does webhook. It's gonna call your endpoint, and then it's gonna pull it, watching for a certain status code. So as long as your integration service framework respects that kind of contract, you will be able to easily integrate it with Spinnaker. So for example, you have a Spinnaker page, it will post to root, and then we basically ping until completion. We know the number of tests that failed and succeeded, and so eventually we actually will be able to kind of build a custom stage UI for that and actually display the results of these tests. So what that looks like in Anchor, we have Marathon. Marathon is fit, that's our fault injection test runner framework. And so if you want to set up Marathon integration tests, it takes you 5 lines of YAML. That will actually add a stage to your pipeline, and now you can actually run integration tests. So we really see Spinnaker as a platform, so these other teams that build these integration test frameworks should be able to plug their stuff into Spinnaker easily. How do we actually do all of this? How do we extend these Java services? So Spinnaker is written in Spring Boot. Spring Boot is very easily configurable, and it allows us to kind of override existing components or basically like plug in new components. So here's an example of us like overriding the Kubernetes manifest handler. So what we do is we basically use Spring Boot annotations to override existing components. And so we don't actually have a fork of Spinnaker. We have our custom annotations, and then we basically compile them together with the Spinnaker source code. And so our stuff actually lives side by side with the Spinnaker source code. So if we do a Spinnaker upgrade, we just pull in the new bill of materials and we're good to go. This comes with some caveats. Some other people that are working on Spinnaker might not be aware that we are actually extending stuff. So we should definitely have a conversation on like what a public API looks like. From what I've heard, there's some work going on around a plugin-based architecture. So there are some caveats. You might override something, and then in a version upgrade of Spinnaker that might actually break, which happened a few times. But this is a pretty good workflow. This allows us to like easily extend Spinnaker, kind of using Spring Boot, which is pretty straightforward. So this is how we extend the backend services. So we extended Cloud Driver, Orca or Sporka, I guess. And we also extended Echo as kind of our event bus for fanning things out. We also extended Deck. So you're looking at a screenshot of deployboard. So remember in the beginning of my presentation, I mentioned that deployboard was also a CI system, or it visualizes CI results. So we don't run Jenkins or anything like that. So we adopted Spinnaker, but we noticed a gap. We didn't actually have a clean way of bridging CI and CD and like kind of visualizing the results of our CI system and the different builds. So deployboard has this snapshots view. It basically shows you all of the commits on a certain branch, and then it also shows you where those are at. So the green P is production, so you like easily know this build is currently running in production. So we started adopting Spinnaker, and people were like, well, where's my build? What's currently running in production? And so we were kind of missing that view. And so we figured we would just extend DAC and kind of build that view into Spinnaker. And that's what we did. So this is the equivalent of the snapshots view, but it's in DAC. So what you can see here is, this is CI. So this is a commit that was merged into the master branch for DAC. And so this is the SHA. You can actually click on this. It will take you to GitHub. If you click on the CI thing, it will take you to build guides. And it also shows you what's currently deployed. So we query Cloud Driver. And so we annotate pods with a SHA. And so we can actually correlate or build with what's actually running on Kubernetes. And so we can actually easily say, like, hey, there are 3 pods in production. This is the replica set that's running this build. So people can just open this up and they know exactly what's running in production. In this case, they don't need to kick off a new deploy. If it was like on build number 2, they might have to deploy a new build. So you can actually select a pipeline from here, which will allow you to trigger a Spinnaker pipeline with the artifact that's associated with that snapshot. So this view kind of allows us to bridge CI and CD at Airbnb. We don't run Jenkins or anything like that that visualizes build results. So this has been kind of useful as like a UX improvement for developers at Airbnb. How do we extend DAC? Initially, we forked DAC. That was difficult. Every time there was an upgrade, we had to pull a bunch of code from DAC in. DAC is undergoing a migration from Angular to React. So it got pretty gnarly pretty quickly. For the snapshots page, we actually realized it's pretty easy to create a new page in DAC. So you can basically create a route, an Angular UI router route. You can set up a data store that's kind of attached to that route and then teach that data store how to fetch data, in our case, snapshots. And so setting up a new page was pretty straightforward, but we also wanted to extend some of the components that are like deeper down in DAC without actually forking DAC. And so we actually realized there was an annotation that someone at Netflix or Google built. Whoever built that, thank you. There is an annotation that you can actually use overridable. You can tag a React component with overridable with a key. So for example, you can say my awesome components, it's overridable. And then what we can do in the Airbnb module is we can override an existing component. So let's say we wanted to change the way a button looks or change the behavior of a button, we can actually easily swap out components at runtime. Very similar to how we do things in Spring Boot. This makes it very easy for us to kind of plug these things in. Our goal is basically everywhere where we use overridable, we'll probably make a PR to use that upstream so that actual like Spinnaker community is actually aware of like which components are being overridden. So there's kind of a touch point there. So that'll make it easier for other developers to also extend Spinnaker, and we'll all know what's being extended and whatnot. So with all that said, that's how we extended Spinnaker. But how do we actually migrate to Spinnaker? How do we force 1,000 services to move to Spinnaker? So in SOA, we have a very rapid growth of services. This is the amount of services in deploy board. I would say about half of those are Kubernetes services. There's also Ruby gems, Java packages. So you can see in 2017, we had about 350 services. Right now, we are about 2,500. So it's really an explosive growth of microservices. So if we want to do this migration, we need to have like a proper plan. So we have a plan for 2019, 2020, and beyond. So basically, we are somewhere in the middle of that plan right now. So what we did in H1 is we wanted to prove that Spinnaker works. So we deployed Spinnaker with Spinnaker. We made it work with OneTouch. And then we had a pilot project with 10 services at Airbnb. And we asked these folks, like, hey, what are you missing? And so we basically, in H2, focused on migrating all of our critical services, like our payment stack. And we used ACA to reduce downtime, and we also wanted to make sure that we can actually prove the value of Spinnaker. So in 2020, we'll GA, Spinnaker will be open for all services. All new services will be on Spinnaker, and then beyond 2020, we'll kind of migrate the long tail of services. So what's our onboarding strategy? We don't want to do a forced migration. We basically want to show people that Spinnaker is an upgrade from deployboard. They shouldn't feel forced to migrate. And so we approached this from the site availability angle. We migrated the most critical services at Airbnb, and we are now proving that ACA can actually increase site uptime. Now that we've proven that, we kind of have a mandate to move people to Spinnaker because Spinnaker is safer than deployboard. So that's how we approach onboarding. We also have a feature roadmap. So how do we actually develop these extensions and features? It's driven by customers. So we reach out to teams with like, what would it take for you to move to Spinnaker? They tell us like, hey, I need a snapshots view. And that's how we come up with all these features that we build. So some examples are people want to like get pinged personally for manual judgments, the snapshots view, ACA configuration as code, ability to mark certain builds as broken when canary analysis failed, and some other features. While we're doing this, we also want to prove that Spinnaker is scalable so that it can actually handle our infrastructure. We are probably one of the larger Kubernetes enterprises on Spinnaker. So we built a service called Deadweight. So Deadweight basically generates artificial Kubernetes services with namespaces and with pods. And we can actually then do something like, hey, let's do 500 concurrent deploys with 50 pods. So we can actually test Spinnaker. Once we have those results, and we'd be happy to share with the community on what we find and where the bottlenecks in Spinnaker are. I wouldn't say Deadweight is really a service. It's more of a series of scripts to kind of stress test Spinnaker. What we also do is we want to generate sane defaults. So we generate a nice default pipeline staging canary production, and then we also give you all of the integration testing frameworks out of the box. So where are we today? We have 40-ish services on Spinnaker. We're about to GA in February. We've already caught 29 incidents that would have been a production rollback if they had gone through, and 90% of our changes on Spinnaker are validated by automated canary analysis. So in 2020, we'll go GA. So any service will be able to onboard onto Spinnaker. It supports all of the core features that are kind of blocking our initial batch of customers. It's production ready. It's been validated by Deadweight so that it can actually handle 1,000 services. So it has the capacity headroom. So what's next? One of the challenges that we had is that continuous delivery is a culture shift. So deployboard allows you to easily deploy to a target immediately. So you can go straight to prod. With canary analysis taking an hour, that kind of changes things. So the workflow is longer, so we need to actually teach people that slow deploys aren't necessarily bad. We want to automate slow deploys so that they don't actually have to check their deployments versus like doing everything manually. So that takes a bit of education on our end to kind of like educate Airbnb developers on continuous delivery. So engineers have to trust the machines rather than looking at dashboards. They actually have to put trust in Kayenta to actually do the right thing. They have to trust the integration test frameworks. So we want to make sure that people actually trust the frameworks that we have and that our tooling is good enough to prevent regressions. We need to make sure that we actually clearly present the benefits of canary analysis. A lot of developers weren't really sure why canary analysis was better for them. They were like, hey, why does this take an hour? Why can't I go straight to prod? I'm sure I won't break things. They did. So then we were like, hey, you should probably adopt Spinnaker. So it's on us to kind of educate people on what the benefits of Spinnaker are and what the benefits of canary analysis are. So what are some opportunities? We have some long tail services in EC2 that might not run on Kubernetes, like Monorail. So maybe we can leverage Spinnaker to deploy to EC2, but we'll have to change our mutable infrastructure to immutable infrastructure. So that's a more long tail endeavor. We want to use Spinnaker as a more general workflow orchestration tool. Things like database migrations, all of these kind of like jobs that we orchestrate. Spinnaker might be a good fit for that. We want to build an ecosystem of stages and tools that developers at Airbnb can plug into Spinnaker and use that, like integration testing. Maybe we want to do Chaos Monkey. Like we really want to build an ecosystem of stages. And then last but not least, we have Trebuchet. Trebuchet launches features at people. It's our feature flagging system. We have a lot of incidents because of Trebuchet. So something gets deployed, but it's actually hidden behind a feature flag. So what if we could roll out a feature to 10, 20, 30, 40% of all of our users, and then use Kayenta to kind of gate those stages and do it more slowly, more safely. That's kind of our future plan. So in conclusion, so what we learned from Spinnaker so far, what is our experience with Spinnaker? I think you should always validate your scalability headroom. We run Deadweight. It costs us a lot of AWS money. but it's worth it. We want to actually make sure that we can actually adopt 1,000 services and don't like be on fire. You need to have a good migration plan. You can't just be like, hey, deploybot is deprecated, everyone has to use Spinnaker now, people will be up in arms, you're changing their workflow. You need to actually make sure that the tool you're bringing on is actually better, usable, has a good user experience, is easy to configure. So get buy-in from your customers, don't force migrate customers. Have the data, show them that canary analysis prevents incidents. That allows you to get like buy-in from even like executive levels. And also don't be afraid to extend Spinnaker. Spinnaker is easily extensible. It's a very easily extensible platform for CD. So Spinnaker doesn't fit every workflow 100%. So what we did at Airbnb is we kind of massaged it into working with our workflow. That's it. If you have any questions, if we have time for Q&A, otherwise just hit me up afterwards.
So you created a new service which called Anchor.
Yes.
When you created the service, did you consider some open source tools like Spinnaker? Because basically it does pretty much the same. You use JSONnet, you create JSON file, and you feed to spin CLI.
Yeah. So OneTouch is using YAML. Also, back in the day, I think JSONnet was still pretty immature. It was like pre-alpha. So it wasn't really an option for us. This was like a year and a half, 2 years ago. I think the reason we also use Anchor is because we can really kind of use Airbnb specific constructs. We can really tie it to our use case. I think if we would reevaluate JSONnet or SPONet these days, it probably would have been a good candidate. But back in the time, it seemed like a good option for us to write a command line tool ourselves.
Okay, and I have a question. For Anchor, are you going to open source it, or it's like specific for Airbnb?
It generates.
Make any sense, open source it.
It generates a bunch of Airbnb specific stuff. I think the general kind of like framework of like configuring stages as YAML we could open source. I don't know if there would be much traction given that tools already exist, but it's something we can consider.